Hi, my name is Kim Binstead, and this week our podcast is about conditional logic in Excel. Just as a quick review, let's go over the three symbols, the three operators that are used in logic. They are not. This is this little right-handed symbol that simply negates the variable that comes after it. Okay, so this reads not X. The next symbol is OR. This is a V shape. So in this case, this means X or Y. And finally, AND. AND is the upward arrow symbol, and this means X and Y. These three symbols together do most of the work in logic. Okay, so I got some feedback from the lecture, and I understand that some of you would like some more information on how truth tables works. So let's go through another example. Truth tables are really useful for breaking down a complex function and understanding what exactly it's going to do. So let's look at this complex function here. It is not X and not Y, or X and Y. Now, it's complex enough that you might not instantly be able to understand in your head what's going to come out. So let's make a truth table. So the first step in understanding a complex function is to see what it's made up of. In this case, we have two variables, X and Y. The X and the Y are then combined in different ways. So the first part involves a not X and a not Y, and they're combined together with an and the second part just has X and Y together. And then those two parts are combined with an OR. So let's break those parts down into the columns of the truth table. X, Y, not X, not Y. Now the not X and the not Y are ANDed together. The X and the Y are ANDed together. And then finally those two parts are combined into the whole function. Okay, so the next step is to come up with all the possible combinations of X and Y. X can be true or false, Y can be true or false. So let's fill in those first two columns. We've got X being false, X being true, and Y being false and true. So now we've got every combination, both X and Y false, X false, Y true, X true, Y false, and both X and Y true. That's all she wrote. So the next column is simply not X. If you recall, not X is the opposite of X. So if X is false, not X is true, and vice versa. So this column is very easy to fill in. We just compare it with the first column and do the opposite. Okay, so the next column is not Y. Just like the previous column, we look at the column for Y and do the exact opposite. So if Y is false, not Y is true, and vice versa. Okay, so now it gets a little bit more complicated. The next column is ANDing together not X and not Y. So we look at the previous two columns, not X and not Y, and look for cases where there's a true in both columns. Because what AND means, AND is only true if the two parts of the AND are both true. So if you look at the previous two columns, on the first row, both not X and not Y are true, so we can say true. But in all of the other rows, there's a false in one or the other of the columns. So in the second row, Y is false, so we can't have the and it's false. In the third row, the not X is false, so again we have to put false. And in the fourth row, both not X and not Y are false, so again we have to put false. That's just the nature of AND. That's what AND means. Okay, so let's look at the next column. This is ANDing together the first two columns, X and Y. Again, we need a case where both are true in order to put true in this column. So in the first row, we have two falses, so this has to be false. The second row, we have a false and a true, so this has to be false. The third row, we have a true and a false, so this has to be false. And then finally, we have two trues, so X and Y can be true. Okay, we're almost there. The final column, which is the whole function, ORs together the last two columns. So if you remember what OR means, OR is true if either one of these columns is true. So the first row, the first of the two columns is true, so we can say true. In the second row, they're both false, so we have to say false. Third row, they're both false, so again we have to say false. And finally in the fourth row, we have a false and a true, so we can say true. Again, it's just the nature of OR. That's what OR means. So this last column is what this function means logically. It means that, not surprisingly, if both x and y are false, then it's true. If both x and y are true, then it's true. And in the other two cases, it's false. You might notice that this is the exact opposite of the exclusive OR function that we went through in class. So conditional logic in Excel can be practical in real life. Let's say you were trying to sort out your opinion on an election. One thing you could choose to do is make a list of the candidates, put those, for example, across the top row, make a list of the issues that you're interested in, you could put those in a column, and then go through and rate each of the candidates on where they stand on each of the issues. Then, once you have this basic data, which you could gather from the candidates' websites, you could come up with a formula, like the ones we've been using so far, to combine together your opinions on the various issues. So, for example, it may be that you think budget and taxes is the most important issue. So you could weigh that column very highly, and you could say that a candidate is no good to you whatsoever, not to that candidate, if their opinion on budget and taxes doesn't match yours. Similarly, you could say that education is second most important, and put that into your function. Finally, you could say things like political reform is not important to you at all, and that column could be left out of the formula putting together your opinion. Now, I'm not saying that you should vote according to a spreadsheet, but this is just a way of organizing information in such a way that it's easier for you to understand and prioritize and use in your life. Importing a text file into Excel. This is usually pretty easy, and I went to the Ironman website, cut and pasted some data into a plain text file, and then substituted commas for the spaces. This made it a comma-separated values file. This is very easy for Excel to import, especially if you remember to save it as a .csv, comma-separated value, file, because then Excel recognizes the extension and knows exactly what to do with the data. However, there's a couple other options you have. One is to use a tab delimited file. So this, instead of commas, uses tabs to separate each field. Another possibility is a fixed width field, where the data fields are aligned in columns with spaces between each field. Now, if you give Excel the right extension for these files, then again, it will understand what you're trying to do and open them properly automatically. However, if you leave the .txt extension or some other extension, then Excel will try to manage the file anyway, and you'll get a text import wizard screen. In this case, all you need to do is tell Excel how you've delimited the data, how you divided it up, and let it go ahead and import the data. So it's a good idea to experiment with this. It's quite flexible, and you'll find that you'll be able to import all sorts of data that already exists without too much tweaking it by hand. Another area where spreadsheets are used, in particular conditional logic and statistics, is in sports. Many sports teams are managed according to a detailed analysis of how each player plays, some of the errors they made, and how they play together.